Hi everyone. So today we are diving into an exciting data science application in the business that optimizes price and discount to maximize sales. That is the problem statement. Whether you are a business owner, data scientist, or just curious about how applied analytics works, this video is for you probably. So here's the problem statement. Imagine you are running a business. There you have a product whose price generally changes over time based on the market demand. Often you'll find this type of products in fashion retail, travels, or at some point in some grocery retails also. You want to find the perfect balance between the price and the discount you offer so that you can maximize the quantity sold. So how you can achieve this? Let's dive into this. Let's break down the problem. So let me show you the data we have right now. Um, I'm going to import this data. I have a CSV file called salesdata.csv. Let me show you what I have. So this data consists of transaction date, price, discount, and quantity. So in that date, this particular product has this price, and you have given 28% of. It's slightly just a little bit higher than 28, and the quantity sold is 17. So why these are in fractions? Because there was a data engineering effort to organize this data, and we have imported the data from an ERP system, which actually gives us the float value. But we can just round it off. Now let's see what is the elasticity of price or the price elasticity of demand. To do that, let's further inspect the data set. Let's describe it. So all we can see that these are some statistics about this data set. And I am going to also print the info. Looks like there are 180 data points, and there is no blank or null valued data or null valued row. It looks like fine. So let's jump into calculating the price elasticity of demand. So what is price elasticity of demand? It's nothing but the percentage change in the price divided by percentage change in the quantity demanded. In other words, you can interpret it as for each percentage change in the price, what is the effect in demand? So let's first calculate the percentage change on the price. And then I'm going to calculate the percentage change in the quantity. We will drop some null value from here or the any value from here. It will generate some. And then I will create a field in the data frame that is called elasticity. And I'm going to print the data head. Let's see. So yeah, this is the elasticity I'm getting for each day. Now, what I can see, there are significant volatility in the elasticity for just for these 5 values. Let's explore more. Okay, let's describe the elasticity itself. Let's see. There are 179 of values because it's taking the just percentage change of the previous with the previous. So what we can see, the mean is -4, and the most significant observation here is the minimum value is -1786, and the maximum is 512. That's a huge window actually. Okay, but we can see the median value is 2. That means the median as +2, which interprets as 1% increase in the price, 2% fall in the demand. or 2% decrease in the demand. Now going back to actual problem statement, we have to find the optimal price point in the next 15 days. Yes, that is another statement that we want to find out what should be our price, optimal price and discount for next 15 days. Okay. So in this case, I'm going to choose some machine learning algorithm to predict the demand of next 15 days. I'm going to choose ARIMA for this particular example. And to fit ARIMA, we need to examine few things on the data set. First, we need to check the stationarity for the quantity. And then we have to find out the ARIMA parameter using autocorrelation and the partial autocorrelation plot. So let's get started into it. First, let me, get this data processing done. First, I will take this data clean data frame and I'll make this date time pandas date time type, and then I'm going to set index as this transaction date. Next, I'm going to plot the quantity sold over the time. Let's see. So yeah, this is the plot. Yeah, this is very tough to say from this plot, at least about the stationarity. I really can't detect any underneath pattern or trend. So let's use some statistical test. It is called augmented decay Fuller test, which checks if a series is non-stationary. So we can say in a statistical way, the null hypothesis is the series is non-stationary. Let's write the code for that. It's very simple code actually. We need to have the stats model, and then we just need to pass this quantity series to this AD Fuller function. Let's see. So from the test, what we get, the ADF statistic is minus 13.77. This value is significantly negative. A more negative value suggests stronger evidence against the null hypothesis, basically. Also, I can say there is a very, very small value for the p-value, which means we can straight away, reject the null hypothesis. Since the ADF statistic is more negative than any of the critical values, the series can be considered as stationary. Commonly used significances here like 1%, 5%, and 10%. And all of the values are, negative. So we can conclude that this particular series is a stationary one. Now we can proceed with identifying the appropriate parameters for ARIMA, that is PDQ value, with the autocorrelation and the partial autocorrelation plot. Let's do that. So first, we have the autocorrelation functions over the lags. Let me interpret it this way. So what I can see, the autocorrelation function tapers off slowly, which suggests that the MA components generally, and the partial autocorrelation function, which indicating the air component, which is also showing that it has a spike at the lag 1. So we can, for this particular video demonstration, let's keep it simple. We can choose the p value or the air order as 1, and the d value, which is differencing order, as 0, as we have already concluded that the series is stationary. And the q value, the MA order, let's keep it 1. Okay. Let's see what is the result. So this is the forecast. And as you see, this the mean value is showing the forecast. The forecast indicates a slightly decreasing trend in the quantity demanded over next 15 days, with the average predicted demand staying close to 17. Yes. The confidence intervals are wide due to the variability in the time series data, suggesting some uncertainty in the exact level of demand. You might be thinking, oh no, my demand is getting low next 15 days, but wait. the statistics or the data science gets you covered here. So we have previous 6 months of data and next 15 days forecast of the demand. We can formulate an optimization problem based on the data forecast we have. So yeah, let's explore this problem. Let's frame this problem this way. We want to keep the price in between 100 to 170, which is what I can see from the data set. And the discount is also between 25 to 35 max. The effective selling price, which is price multiplied by 1 minus discount, should not drop at least 85 so that you don't make loss. Okay. So before we proceed with this optimization, we need to define the objective function, which in this case should reflect how quantity varies with the price and discount. For this beginner-friendly demo, we initially assume a linear relationship based on an observed trend or the past data. Alternatively, you can use a non-linear or any machine learning algorithm um, to find out such a complex relationship between these two variables. Now, let me know in the comment. It's very, let me know in the comment how we can use other machine learning models such as random forest in this scenario. Or let me know if you want me to do another demo to show how we can use other machine learning models here. Okay. So let me write down it, our assumption, what we are going to do for this objective function. We are going to take this function. Let me just put it in a markdown, that q beta 0, beta 1p and beta 2d, where q is the quantity sold that we want to maximize. Beta 0 is the intercept, beta 1 and beta 2 are the coefficient for the price and discount. As I already said that we are going to use linear model for that. So I have the code, let me run it. So what we are doing, we are just taking the features as price and discount. We are making the target variable as quantity that we want to predict. Okay, let me run this code. Great. So what we can see, coefficient for P here, the price is this one is very non-significant, I can see. And the coefficient for the discount is a positive significant value. So now based on this, we can write, okay, let me write the optimization problem in this way. Let's see, just let me write this down in my just let me write down this in my notepad, and I'm going to put it here. Yes, so what we want to do, our price constraint is always in between 100 and 170. Discount should be within 25% to 35, and our selling price, that is price multiplied by 1 minus discount, is always greater than 85. Okay, let's proceed with the optimization function. I have already written this code for sake of this video. Let me put it out here. So this is the objective function that I have two variables as x, and these are the this is the intercept, and this is the coefficient of discount that I have taken here, which is 200, which is actually a positive significant coefficient. And there are I have defined the constraint here. Okay, so it's not a coding demonstration right now. It's just I'm going to show how it works. And the initial guess that I'm taking, that the price should be 135 and the discount should be 30%. Okay, let's see what it does. Great. It says that the optimization has terminated successfully. That means it has converged. So from this result, what I am getting actually, this is saying that let's keep the optimized price at 135 only. but it has found out a discount that optimal discount that is 35%. So it is asking that if we priced it at 135 and if we put discount 35%, then our forecasted sales or the optimized quantity of this product should be 30. Let me interpret it this way. So the optimization problem has concluded that keep the price at 135 with 35% of discount, you will get at least 30 sales over the next 15 days. Now, let's see. I want to change the discounts a little bit. Let's say, okay, what if I'm just lowering down the discounts to 30%? What would be the impact in my sales? With the same type of codes, the same type of optimization, I have just fixed the discount as 30%. Let me run it. So it says that if you keep your price at 135 and with the 30% of discount, your forecasted sales is 20. Now, probably you have got the notion of this particular demo that we can simulate. So how does this particular exercise helps in the business? First, you can predict the demand on next few days, what is coming for your business, and that way you can strategize your pricing and discount so that you can get optimal sales. You should not get lesser sales, you should not get you should not expect higher sales with the higher profit. This can give you a definitive guide for a data driven sales and pricing strategy. Now I can say optimizing business strategies using data science not only enhances the profitability but also provides the clear insights into how different variables affect the outcomes. Today we have probably we have seen that how to use data analysis, linear regressions, time series analysis, and optimization techniques to make data driven decisions. Thanks for watching. If you enjoyed this walkthrough, or if you have any questions or topic you want me to cover, drop them in the comments below. See you in the next video.